This mini lecture is on conformations of cycloalkanes. Well, first of all, take a look at cyclopropane. As you can see, the bond angle on cyclopropane is 60 degrees. That's the angle you'll find in an equilateral triangle. And if you think about what the bonds want to be, they want to be at 109.5 degrees because these are all supposed to be sp3 hybridized carbons. But they're at 60, which makes this a pretty strained type situation. Now, the other problem this has is the eclipsing that goes on with all of these hydrogens. Take a look. See, all these hydrogens are eclipsed and they can't move out the way of each other, so they're pretty much stuck there. Not a very stable situation. Alright, take a look at cyclobutane. 90 degrees, still 109.5 is what it wants to be, so these aren't that happy either. But this is not quite as bad as cyclopropane because this can shift out of the plane and form that kind of situation, so it's not quite as bad. Alright, let's take a look at cyclopentane. Now, cyclopentane is in a pretty good situation. It looks as though these are all eclipsed, but cyclopentane can do something that the other ones can't do. It can shift out of the plane into a shape that looks a lot like an envelope. So you've got one carbon down here and the other carbon's like this, but this is not a static situation. This particular carbon that's pointing down moves all around the ring, so it's in a constant rotation, so that the hydrogens are never completely eclipsed with each other. So that's a good situation for cyclopentane. The other thing it has going for it is its 108 degree bond angles, which are pretty close to being 109.5, what it really wants to be. So that's an envelope conformation. The next one, cyclohexane. Cyclohexane, like cyclopentane, can do some shifting so that it doesn't end up in the same situation as these guys do. So it can shift out of the plane and become something that looks like a chair. So that's called a chair conformation. And it does this to avoid the problems of eclipsing that the other ones suffer. Now, there's two kinds of bonds that we're going to see. We're going to see the hydrogens that stick directly up and down. These are called axials. And then you've got the equatorials. Those are the ones that are around the edge. So think of it like the Earth, where you've got the poles, which run along the axis, and then you've got the equator. So you've got the axial ones that run up and down. You've got the equatorial ones that run around the side. I'll be showing you how to draw those in a little bit. And the other thing we're going to see is that there'll be some interconversion going on between these hydrogen atoms. And we're going to see this chair-chair interconversion. One chair form to another chair form. And this is how it happens.